So next, let's go over 3 very important properties of functions. And these ones will apply to any functions, not just those going from or to the real numbers. So they're called injective, surjective, and bijective. So let's get straight in. So a function from a set A to a set B is injective, aka one-to-one, or this is not a good way of saying it in general, or I mean, this shouldn't be the only way that you say it, but often is denoted by putting a little hook on the end of your arrow. I mean, even make that a little bit more dramatic, like that. So a function is injective if it satisfies this condition: f of x equals f of y implies x equals y. So let's think about what this means. This means every element of B has at most one preimage. So if you have 2 elements, well, let me draw a picture. So if you have 2 elements in your domain, they cannot collide. So this is exactly the kind of thing that is not allowed. Because this is when you have, so if this is x and this is y, you have f of x equals f of y, but x does not equal y. So that's the only thing that this is what you're disallowing, right? So what you're saying is that each of these elements goes to a different guy. This is what an injective map looks like. And this is the same as saying that each guy here has at most one preimage. But of course, it can have 0 preimages. That is allowed. This is injective. Let's give them all in a row, and then we'll see some examples. F is surjective, aka onto, and commonly denoted with this double pointed arrow. If for every element of B, there is an element of A that maps to it. So what this is saying, injective was saying that every element of B has at most one preimage. Surjective is saying that every element has at least one preimage. So let me emphasize that even. So what does this look like? Let's draw another picture. So here, you can certainly have collisions. That is not the thing we're disallowing. What you can't have is a situation where there's a lonely guy with no arrows, right? We're requiring that every element of B has to have an arrow going to it. So this is what a surjective map looks like. Everyone has at least one preimage, like this, but you can certainly have more. And finally, F is bijective, aka one-to-one correspondence. And can be denoted by either an arrow with a squiggly on top of it, or a double-sided arrow. And what this means is that it is injective and surjective. Which of course means that it has at most one and at least one preimage. Which is to say it has exactly one. So what a bijection means is that every element of B has exactly one arrow coming into it. So basically you're matching up the elements of A and B exactly. Something like this. So there's no collisions, and there's no guy in B that has no arrows coming into it. So, oh, let's get a new page, and then do some examples. All right. So if we consider this multiply by 2, map from the integers to the integers, this is injective because if 2x equals 2y, that does indeed imply that x equals y, because you can divide by 2. But it is not surjective because, for example, well, every odd number will not have a preimage because you cannot write 3 as twice another integer. On the other hand, if we think of this as a function from the real numbers to the real numbers, it is still injective for the same reason. But now every number can be divided by 2, and you'll still end up with a real number. So it is also surjective. Therefore, it is a bijection. So I'm not going to write this down, but maybe just to say the words clearly once. If a function is injective, I call it an injection. And if it's surjective, it is a surjection. And if it's bijective, it is a bijection. So that's just the adjective versus the noun. And I guess I wanted to make a comment as well on these names, which is that normally I like to use more down-to-earth names if there are options, but somehow the words injective and surjective and bijective are so deeply ingrained that I'm going to use those words even though they are a little bit less illuminating. So I hope that is something that you can get used to. But of course, you're free to call them one-to-one and onto, and one-to-one correspondence are also excellent names for them. So this guy that we just talked about is an example of, note that a strictly increasing function will always be injective. So for example, this function is strictly increasing. If x is bigger than y, then 2x is bigger than 2y. and that will always be the case that it is injective for a strictly increasing function. And I believe this is a nice practice problem that I will post to prove that this is the case. Strictly increasing functions are always injective. Here is another example. So let's say divide by 5 and take the remainder. Gives a map from the integers to the set 0 to 4. Because if you divide by 5, these are the possible remainders. So this is not injective. For example, 1 and 6 both have remainder 1. But it is surjective. Because, for example, what is an example of a number that has each of these remainders? You can just take that number itself. So if, for example, 3 will have remainder 3. No problem. So this is a function that is surjective, but not injective. And this is also a little preview of modular arithmetic. Which we'll be seeing very soon. I think even later this week, we'll start talking about modular arithmetic. Great. Another quick example for people who are into calculus, this running example that I keep giving. The derivative, which is a function from the set of functions R to R, which are differentiable, to the set of functions from R to R, is not injective nor surjective. And if you're interested, it might be fun to check this, come up with some interesting examples. And finally, I want to revisit another question that came up last time, which is that, is A cross B the same thing as B cross A? So remember, this is the Cartesian product, which consists of ordered pairs of one element from the first set and one element from the second set. So let me elaborate on the answer that I gave last time. These, which may not be recorded if you're watching the recordings, but these sets are not equal as sets, but there is a natural bijection from A cross B, and let me write it like this, which, if you have a pair little a comma little b, gets matched up with little b comma little a. So technically speaking, these are not the same set, but there's a natural bijection that you can use to treat them the same way if you want to.